In this session, we are going to discuss the topic mensuration. Mensuration is a branch of mathematics that deals with the study of geometric shapes, where we measure the areas, volumes, and related parameters of various geometric shapes with the help of simple algebraic formulae. Geometric shapes can be generally classified into two types: two-dimensional shapes and three-dimensional shapes. For two-dimensional shapes, we measure area and perimeter. And when it comes to three-dimensional shapes, we generally measure the volume and total surface area, or the curved surface area, as the case may be. Now, to solve various questions from this topic of mensuration, the relevant formula, that is formula for area, perimeter, volume, etc., is required to get the answer. So it is very much essential that we know all these relevant formulae of different geometric shapes before we solve various questions. So you all are supposed to refer the textbook of Quantitative Aptitude and learn all these formulae by heart. Remember friends, without knowing the relevant formula, it is not possible to solve questions from this topic. Why? Because basically mensuration is a formula oriented topic. So make sure that you learn all those formulae which have been given in the textbook. Before we take up different questions, let us first understand what is the difference between two-dimensional shapes and three-dimensional shapes, and what is actually meant by the various parameters like area, volume, perimeter, etc. Now, as I've mentioned, geometric shapes can be generally classified into two types. One is 2D shapes, that is two-dimensional, and the other one is 3D shapes, that is three-dimensional. So let us first understand what is meant by a 2D shape, a two-dimensional shape, or a two-dimensional figure. Any figure or shape that is bounded by three or more straight lines or a closed circular line is a plane figure, or it's called a 2D figure, two-dimensional figure. So any shape that is bounded by three or more straight lines or three or more line segments or a circular line, a closed circular line, is called a two-dimensional shape. For all these shapes, there is no depth or height. That means these shapes have got length and breadth. They have got two dimensions, but they have not got any depth or height. That means it is difficult to hold these shapes. The thickness of these shapes is equal to 0. But in real world, there is no shape where the thickness is 0. But we can say that the thickness or the depth is negligible. Now, the various examples of two-dimensional shapes are circle, square, rectangle, triangle, etc. And these shapes have been given here. So the first one that you see here is a circle. As you can see, going by the definition, any figure that is bounded by a closed circular line can be called a 2D figure. Now here, this is a closed circular line. This is a bounded shape. So hence, this is a two-dimensional shape, which is called as circle. The next one here we have is a square, where all the four sides are equal. Now this is the shape which is bounded by four straight lines of equal length. The next one that we have here is a rectangle. Now again, if you observe, this is a shape that is bounded by four lines. Now the difference between a square and a rectangle is that in case of square, all the four sides are equal. But in case of rectangle, all the four sides are not equal. But only the opposite sides are equal. That means here the two opposite sides are equal and these two opposite sides are equal. Whereas in case of square, all the four sides are equal. And then the next example that we have here is for a triangle. Now triangle can be of various shapes, and it can be classified into different types like equilateral triangle, right angle triangle, isosceles triangle, or scalene triangle. And relevant formulae for all these types of triangles have been given in the textbook. But in general, a triangle is a figure that is bounded by three straight lines. So this is what a triangle looks like. Now, as I have mentioned, for two-dimensional figures, we measure area and perimeter. So all the formulae of area and perimeter are there in the textbook, but let us understand what is actually meant by area and perimeter for a 2D figure. In simple words, area can be defined as extent of surface, or nothing but the surface occupied by the given shape. For example, when we take the circle, area of the circle is nothing but that surface which is occupied by the closed object here, or by the closed shape here. Similarly, for a square, area is this region that is occupied by the closed boundary. Similarly, for rectangle and triangle, again, area is nothing but the region or the surface that is occupied by the closed shape. So in simple words, we can say that area is nothing but extent of the surface. And in general, area is measured in terms of centimeter square or meter square. These are the standard units of measurement for area. Now let us understand why is area measured in terms of meter square or centimeter square, or what does it actually mean by a meter square. When we say 1 meter square, it is nothing but the area occupied by a square of side 1 meter. For example, let's say this is a square of side 1 meter. All the sides are equal, 1 meter. So the area occupied by this square, this region occupied by the square is 1 meter square, So when we measure the area of any type of 2D figure, we try to refer with respect to 1 meter square of area. For example, if you take this rectangle, let's say it can be divided into different squares. Let's say here we have 12 squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. And each of these squares here is of area 1 meter square. So as you can see, the total number of squares that we have are 12. So we can say that area of this rectangle is 12 meters square. So when we say the area of a particular shape is 12 meters square, it means it is equivalent to 12 squares of side 1 meter each. Likewise, area of triangle can be measured in terms of meters square. Again, we try to understand how many squares of side 1 meter are there which have occupied this complete extent of the given triangle. And even in case of a circle, it is measured in terms of meter square or centimeter square as the case may be. So whatever be the geometric shape, we try to split it in terms of number of squares of side 1 meter each or 1 centimeter each. And then the count of those many squares will give us the area in terms of meter square or centimeter square respectively. But friends, one important point that we need to understand here is, while actually finding out the area of different shapes, we don't try to break it into different squares of 1 meter or 1 centimeter. We have direct algebraic formulae that can give us the area of these various geometric shapes. For example, area of a circle can be measured as pi r square. Pi r square, where r is nothing but the radius of the circle. Radius of the circle is nothing but the length from center of the circle to its boundary. So this is called radius. So if the radius is given, area can be taken as pi into r square. Pi is a constant 22/7 and r is the radius. So simply by doing the calculation of pi r square, we can say what is the area of the circle. Likewise, for a rectangle, we need not actually break into number of squares. We can say that area of rectangle is length into breadth. Similarly, for triangle, we have got different formulae for different types of triangles. So as such, we need not worry about how to break it in terms of different squares. If you remember the formula of area, that will give you the answer directly. Now the next thing that we measure for a two-dimensional shape is perimeter. Perimeter in simple words can be described as the length of the boundary or the length of the outline. As we know, all these two-dimensional shapes are closely bounded shapes. So the length of that boundary is nothing but the perimeter of that shape. And the units of measurement are centimeter or meter. So simple words, perimeter is a length of the boundary. And length we know is measured in terms of centimeters or meters. For example, for a circle, the perimeter is nothing but the length of its boundary. So this length, when we measure, we get the perimeter of the circle. And in general, for a circle or ellipse, it is referred as circumference. The perimeter is referred as circumference. For a square, the perimeter is nothing but again the length of the outline. So measurement of all these lengths will give us the perimeter. For example, let's say the sides are 1 meter each. So the perimeter of this square will be 1 plus 1 plus 1 plus 1. That is 4 meters. Likewise, length and breadth will be given. We can find out the perimeter for rectangle or triangles as the case may be. Again, for perimeters as well, we have direct formulae. For example, perimeter of a circle is 2 pi r, where r again is the radius of the circle. Similarly, for a rectangle, the perimeter is 2 times length plus breadth. All these formulae, as I've mentioned, are there in the textbook. You need to remember those formulae to solve various questions from this topic of mensuration. So these are the two important parameters that we measure for two-dimensional shapes, area and perimeter. Area is nothing but the surface occupied or the extent of surface. Standard unit is meter square or centimeter square. And perimeter is the length of the boundary, which is measured in terms of centimeters or meters. Let us now understand what is meant by a three-dimensional shape and what are the different parameters that we measure for 3D shapes. A 3D shape or figure is the one that is bounded by a number of surfaces or planes. These are also referred as solid shapes which have got length, breadth and depth. So if you try to understand the definition, a three-dimensional shape or a three-dimensional figure is nothing but the one which is bounded by a number of surfaces or planes. Now if you try to understand, a surface or a plane is nothing but a two-dimensional shape. So a 3D figure or a 3D shape is made up of a number of two-dimensional shapes, that is nothing but surfaces or planes. So whenever different surfaces are combined together, we get a three-dimensional shape. And as given here, these are also called as solid shapes which have got length, breadth and depth or height. If you try to compare the 2D shape with a 3D shape, in a 2D shape, as we have discussed, there is no depth or height. It is negligible or zero. But in case of a 3D shape, there is a definite depth or height. So these are the three dimensions that we have for a 3D shape: the length, breadth and the depth. Whereas in case of a 2D shape, there is only length and breadth but no depth or height. That means in 2D shape the thickness is 0, but in case of 3D shapes there exists some thickness for the given shape. Some examples of 3D shapes are sphere, cube, cuboid, cylinder, cone, etc. There are many more 3D shapes, but when it comes to bank exams, they generally concentrate on these type of 3D shapes. Now what is meant by a sphere? If you can understand, a sphere is nothing but a perfectly rounded object. That's like a ball-like structure. So anything which appears like a perfectly rounded object or like a ball can be considered as a sphere. A cube is like a squared box, a box which is in shape of a square from all the sides. A cuboid is like a rectangular box. Cylinder, as we know, is the one which has got the base and top as a circular surface and it is bounded by a curved surface. For example, this pen here can be taken as a cylinder. The base is circle, top is circle, and then there is a lateral curved surface. So such a figure is referred to as a cylinder. And cone, we very well understand, is the one where the base is circle but the top is a singular point. So a cone is like a special type of cylinder. The base is circle, but as we move upwards, the radius of the circle decreases and it converges to a single point. So circle becomes a point as we move from bottom to top. So that kind of a figure is referred to as a cone. It is difficult to draw all these 3D figures on a 2D surface like a board or a paper. Why? Because a board or a paper has got only 2 dimensions and hence we cannot put a 3-dimensional figure on this paper or board. But this is an angular view of a 3D shape. This, as you can see, is a cuboid which has got length, breadth and height. So this is the length, breadth and height. All these 3 may be different or may be equal. So such a figure is called a cuboid. This is like a rectangular box. Now if you try to observe, this cuboid here is made up of 6 different planes. 4 lateral surfaces or the 4 surrounding surfaces, the base and the top. So 4 plus 2, total 6 surfaces. So 6 2D shapes will combined together will give us a cuboid. Likewise, when all the length, breadth and height become equal, it appears like a cube. That is like a squared box. Again, in case of a squared box or a cube, there are 6 surfaces or 6 2D shapes. So that's how a solid is always made up of a combination of 2D shapes, or it is bounded by 2D planes or 2D figures. For example, this cuboid, as we can see, is made up of 6 plane figures or 6 2D figures, where each figure may be a rectangle or a square. Similarly, a cube is made up of 6 squares, 6 2D shapes which are like squares. Now when it comes to solids or 3-dimensional shapes, we generally measure volume and surface area. So let us understand what is meant by volume and surface area for 3D figures. Now volume, as given here, is nothing but the space enclosed. One simple way to understand what is volume is space enclosed. So volume is that quantity which talks about the space contained within the 3-dimensional shape. So as we have seen in case of area, area was surface occupied, whereas volume is space occupied. Space is nothing but 3D and surface in case of area is 2D. So the 2D surface which is occupied is area. The 3D space occupied or enclosed is volume. So that's the major difference between area and volume. And volume is generally measured in terms of centimeter cube or meter cube. These are the standard units. So like as we have seen in case of area, we measure area in terms of meter square, where meter square is the area of a square of side 1 meter. Here volume is measured in terms of meter cube. So 1 meter cube is the volume occupied by a cube of side 1 meter. So again, this cuboid here can be constructed in terms of number of cubes of side 1 meter each. So the count of those cubes will give us the volume of the cuboid. So that is the reason we use units as meter cube or cubic meter or centimeter cube or cubic centimeter. And remember again, it is not necessarily that it should be meter cube or centimeter cube. These are the standard units. Otherwise, it can also be in millimeter cube or cubic feet or feet cube, etc. The other parameter that we measure for a 3D shape is the surface area. Now surface area again can be of different types. Total surface area TSA, lateral surface area LSA and curved surface area CSA. So let us understand what is meant by each one of them. Total surface area is the total area of all the surfaces. For example, in this cuboid, we have got 6 surfaces. So when we add up all the areas of these 6 surfaces, we get the total surface area of the cuboid. And we know that area is measured in terms of meter square or centimeter square. So here again, total surface area is nothing but a type of area. So it should be measured in terms of meter square. Likewise, lateral surface area. Lateral surface area is the total area of only the lateral surfaces. Lateral surfaces are nothing but those surfaces which are surrounding the object. So the surrounding surfaces here are 4. So when we add up the area of all these 4 surfaces, we get the lateral surface area, which again is measured in terms of meter square or centimeter square. And the last one here is curved surface area. So in those solid shapes where there is a curved surface, the total area of only those curved surfaces is referred to as curved surface area. For example, in a cylinder, as we have seen, this is a cylinder. So where the base is circle, top is circle, and there is a curved surface. So area of this surface which is surrounding the cylinder is referred as curved surface area. And the total surface area would be area of base plus area of top plus the area of the curved surface. So total surface area is the total of all the surfaces. Curved surface area is the total area of only the curved surfaces. And lateral surface area is nothing but the total area of only the lateral surfaces. With this, we can clearly understand that the 2 types of geometric shapes that we have are 2-dimensional and 3-dimensional. For 2-dimensional shapes, we measure area and perimeter. For 3-dimensional shapes, we measure volume and surface area. So friends, make sure that you take up all the formulae of these different types of geometric shapes from the textbook and learn them by heart. Why? Because without these formulae, we will not be able to solve the different questions from this topic of mensuration. तो चलिए अब डिस्कस करते हैं मेंसुरेशन से मॉड्यूल 1, जहां पर हम बेसिक 2D और 3D शेप्स रिलेटेड क्वेश्चन सॉल्व करेंगे। जनरली इन क्वेश्चंस को हम फॉर्मूला अप्लाई करके सॉल्व कर सकते हैं। देखते हैं फर्स्ट एग्जांपल। द रेशियो बिटवीन पेरीमीटर एंड ब्रेड्थ ऑफ ए रेक्टेंगल इज 5:1। If the area of the rectangle is 216 square centimeter, what is the length of the rectangle? So जैसे क्वेश्चन में दिया गया है, किसी रेक्टेंगल के पेरीमीटर और ब्रेड्थ का रेशियो है 5:1 और रेक्टेंगल का एरिया है 216 स्क्वायर सेंटीमीटर्स। और इस दी गई इंफॉर्मेशन में से हमें ये पता लगाना है कि लेंथ ऑफ द रेक्टेंगल क्या होगी, राइट? तो देखते हैं इसे कैसे सॉल्व करेंगे। फर्स्ट स्टेटमेंट में जैसे दिया गया है पेरीमीटर और ब्रेड्थ रेशियो है 5:1, तो हम कह सकते हैं पेरीमीटर P बाई ब्रेड्थ B इक्वल्स टू 5/1। और हम जानते हैं कि रेक्टेंगल का पेरीमीटर होता है 2 टाइम्स ऑफ L प्लस B, राइट, वेयर L इज द लेंथ एंड B इज द ब्रेड्थ। सो P को हम सब्स्टिट्यूट करेंगे 2 इंटू L प्लस B से, डिवाइडेड बाई B इक्वल्स टू 5/1। अब इसे क्रॉस मल्टीप्लाई करके हम लेंथ और ब्रेड्थ के बीच का रिलेशनशिप एस्टैब्लिश कर सकते हैं। तो जब हम इसे क्रॉस मल्टीप्लाई करेंगे क्या होगा, 2 इंटू 1 इज 2, सो ये हो जाएगा 2L प्लस 2B इक्वल्स टू 5 इंटू B विच इज 5B। यानी इसमें से हम कह सकते हैं 2L इक्वल्स टू 5B माइनस 2B 3B, 2L इक्वल्स टू 3B या फिर B इक्वल्स टू 2L बाई 3। सो ये हो गया ब्रेड्थ और लेंथ का रिलेशनशिप। यानी इस रेक्टेंगल की ब्रेड्थ है 2/3 टाइम्स द लेंथ। अब जो नेक्स्ट पॉइंट है वो है एरिया। एरिया ऑफ द रेक्टेंगल इज 216 स्क्वायर सेंटीमीटर। एरिया ऑफ द रेक्टेंगल क्या होता है, लेंथ इनटू ब्रेड्थ, राइट? ये बेसिक फॉर्मूले हैं पेरीमीटर और एरिया के। एरिया है लेंथ इनटू ब्रेड्थ, जो कि दी गई है 216 स्क्वायर सेंटीमीटर्स। एरिया है 216 स्क्वायर सेंटीमीटर्स। अब ब्रेड्थ हम जानते हैं कि 2L/3 है, राइट? ब्रेड्थ को हमने लेंथ के टर्म्स में ऑलरेडी एस्टैब्लिश किया है 2L/3। तो इसी इक्वेशन को हम एरिया के फॉर्मूले में सब्स्टिट्यूट करके लेंथ कैलकुलेट कर सकते हैं। देखते हैं कैसे करेंगे, राइट? सो यहां पर क्या हो जाएगा, लेंथ L, ब्रेड्थ हम ले सकते हैं 2L/3। सो ये हो जाएगा 2L/3 इक्वल्स टू 216। अब इसे सिंप्लीफाई करने पर क्या आएगा, L इंटू L हो गया L स्क्वायर और ये 2 हो जाएगा 108 टाइम्स, यहां पर 3 इंटू 108 होता है 324, यानी L स्क्वायर इक्वल्स टू 324। L क्या होगा, स्क्वायर रूट ऑफ 324। स्क्वायर रूट ऑफ 324 होता है 18। सो इस क्वेश्चन का आंसर हो जाएगा 18 सेंटीमीटर्स। ध्यान रखें लेंथ सेंटीमीटर्स में मेजर की जाएगी। क्यों? क्योंकि एरिया स्क्वायर सेंटीमीटर में दिया गया है। अगर एरिया स्क्वायर मीटर्स में दिया गया हो तो लेंथ हो गई 18 मीटर्स, राइट? सो हमें बेसिकली जो दी गई यूनिट्स है उन्हीं से कंपेयर करके
यहाँ पर यूनिट्स मार्क करने हैं। तो इस क्वेश्चन का फाइनल आंसर होगा लेंथ ऑफ द रेक्टेंगल इज 18 सेंटीमीटर्स। इसी प्रकार से अगर ब्रेड्थ पूछी जाए, राइट, व्हाट इज द ब्रेड्थ ऑफ द रेक्टेंगल, तो हम क्या करेंगे, ब्रेड्थ को 2l/3 सब्स्टिट्यूट करने की जगह लेंथ को 3b/2 सब्स्टिट्यूट करेंगे, ताकि हमें एक इक्वेशन आ जाए ब्रेड्थ के टर्म्स में, और उसे सिंप्लीफाई करके हम ब्रेड्थ कैलकुलेट कर सकते हैं। तो ये है एग्जाम्पल 1 मॉड्यूल 1 से, जो कि बेसिक रेक्टेंगल पर बेस्ड क्वेश्चन है। और जैसे आपने देखा, इसे सॉल्व करने के लिए हमें एरिया और पेरीमीटर दोनों के फॉर्मूले पता होने चाहिए, अदरवाइज इसे सॉल्व करना डिफिकल्ट हो जाएगा। चलिए अब डिस्कस करते हैं एक और एग्जाम्पल मॉडल 1 से। तो यहां पर क्वेश्चन है, द वॉल्यूम ऑफ ए सर्कुलर कोन इज 100 पाई सेंटीमीटर क्यूब एंड इट्स हाइट इज 12 सेंटीमीटर्स। व्हाट इज द स्लैंट लेंथ ऑफ द कोन। सो इस बार अगर आप देखें, क्वेश्चन है 3D शेप पर। लास्ट टाइम हमने क्वेश्चन सॉल्व किया था रेक्टेंगल पर बेस्ड, जो है 2D शेप, लेकिन इस बार है 3D शेप, जो है कोन। तो यहां पर हमें कोन की वॉल्यूम दी गई है, जो है 100 पाई सेंटीमीटर क्यूब, और हाइट भी दी गई है, जो है 12 सेंटीमीटर्स। हमें क्या पता लगाना है, स्लैंट लेंथ। तो सबसे पहले कोन के फिगर को कंसिडर कर लेते हैं, देखते हैं स्लैंट लेंथ क्या होती है। अब अगर आप इसे देखें, वैसे तो बोर्ड पर कोन ड्रॉ करना मुश्किल है, क्योंकि जैसे मैंने बताया 2D सरफेस है ये बोर्ड, और 3D फिगर ड्रॉ करना मुश्किल होगा। लेकिन अगर आप इसे एंगुलर व्यू में विजुलाइज करने की कोशिश करें, तो ये हो गया एक कोन का शेप, राइट, जो बेस है सर्कुलर है और बाकी स्लैंट लेंथ है। अब यहां पर इसे हम हाइट कहते हैं, राइट, हाइट h, कोन की हाइट हो गई h, राइट, और ये हो गया रेडियस r, राइट, रेडियस ऑफ द बेस। जो बेस है वो एक सर्कल है, राइट, तो सर्कल का रेडियस होगा, और इस डायमेंशन को हम स्लैंट लेंथ कहते हैं। ये हो गई स्लैंट लेंथ l। तो अगर आप ध्यान से देखें, हाइट, रेडियस और स्लैंट लेंथ, ये तीनों को मिलाकर एक राइट एंगल ट्रायंगल बनता है, क्योंकि यहां पर एंगल होगा 90 डिग्रीज, राइट। तो यहां पर हमारे पास एक राइट एंगल ट्रायंगल है। ये हो गई हाइट h, और ये है रेडियस r, और स्लैंट लेंथ l। और जैसे क्वेश्चन में दिया गया, हमें स्लैंट लेंथ कैलकुलेट करनी है। अब स्लैंट लेंथ अगर कैलकुलेट करनी हो तो हमें हाइट और रेडियस दोनों पता होनी चाहिए। हाइट तो क्वेश्चन में दी गई है 12 सेंटीमीटर, लेकिन रेडियस हमें कैलकुलेट करना होगा। और जैसे ही हाइट और रेडियस आ जाते हैं, हम पाइथागोरस थ्योरम अप्लाई करके स्लैंट लेंथ कैलकुलेट कर सकते हैं। तो देखते हैं रेडियस हम कैसे मेजर करेंगे। दूसरा जो पॉइंट हमें क्वेश्चन में दिया गया है वो है वॉल्यूम। वॉल्यूम ऑफ द कोन इज 100 पाई सेंटीमीटर क्यूब। अब वॉल्यूम का अगर आप फॉर्मूला लें कोन का, वो होगा 1/3 पाई r² h। यहां पर पाई है कांस्टेंट, r है रेडियस, और h होगी हाइट ऑफ द कोन, जो कि कितनी दी गई है हमें, वॉल्यूम ऑफ द कोन कितनी है, 100 पाई, राइट। और हमें हाइट भी दी गई है क्वेश्चन में 12 सेंटीमीटर। तो इस 12 सेंटीमीटर हाइट को हम फॉर्मूला में सब्स्टिट्यूट कर सकते हैं। तो ये हो जाएगा 1/3 पाई इंटू r² इंटू 12 इक्वल्स टू 100 पाई। अब अगर इसे हम सिंप्लीफाई करें, पाई और पाई कैंसिल हो जाएंगे, 3 यहां पर कैंसिल होगा 4 टाइम्स, 4 हो जाएगा 25 टाइम्स, यानी r² इज 25। अगर r² 25 हो तो r होगा 5, रेडियस होगा 5 सेंटीमीटर। यानी अब हमें रेडियस और हाइट दोनों पता है, और इस राइट एंगल ट्रायंगल में पाइथागोरस थ्योरम अप्लाई करके हम स्लैंट लेंथ कैलकुलेट कर सकते हैं। तो स्लैंट लेंथ कितनी होगी, स्लैंट लेंथ l होगी √h² प्लस r²। तो इसे हम कैलकुलेट कर सकते हैं। h², 12² होगा 144, एंड r² है 5² जो है 25। 144 और 25 होता है 169, स्क्वायर रूट ऑफ 169 हो जाएगा 13 सेंटीमीटर। यानी इस क्वेश्चन में जो स्लैंट लेंथ है कोन की वो होगी 13 सेंटीमीटर। तो जैसे आपने देखा बहुत ही सिंपल क्वेश्चन है, बस इतना ही है कि आपको फॉर्मूला पता होना चाहिए। कौन सा फॉर्मूला, वॉल्यूम ऑफ द क्यूब, क्योंकि यहाँ पर क्वेश्चन वॉल्यूम ऑफ द कोन, क्वेश्चन में हमें वॉल्यूम दी गई है। और दूसरा ये कि हाइट, रेडियस और स्लैंट लेंथ मिला के एक राइट एंगल ट्रायंगल बनता है, जहां पर रेडियस होता है बेस ऑफ द ट्रायंगल, हाइट है परपेंडिकुलर साइड ऑफ द ट्रायंगल, और स्लैंट लेंथ होती है द हाइपोटेन्यूज ऑफ द ट्रायंगल। सो हाइपोटेन्यूज स्क्वायर इक्वल्स टू बेस स्क्वायर प्लस परपेंडिकुलर साइड स्क्वायर, फॉर्मूला हम अप्लाई करके स्लैंट लेंथ मेजर कर सकते हैं। तो फाइनल आंसर होगा 13 सेंटीमीटर।
Let us now take the next set of questions from this topic of mensuration, where we have to indirectly use either the formula of perimeter or the area of a two-dimensional shape to get the required answer. Let's look at the first example. A fence is to be drawn around a circular ground of radius 7 meters. What will be the total expenditure if the cost of fencing is rupees 120 per meter? So here we are supposed to find out the total expenditure if the cost of fencing is rupees 120 per meter. So So as given in the question, there is a circular ground. Let's take this as a circular ground. Radius is 7 meters. And fence is to be drawn around the circular ground. That means fence has to be put across this circular ground. Now as you can see, when we put a fence around a circular ground or any two-dimensional shape for that matter, we are actually working on the perimeter. That means here, first of all, to find out the total cost, we need to know what is the length of the boundary. Why? Because a fence is nothing but the boundary. We are working on the boundary. So until and unless we know the length of the boundary, we cannot go ahead for calculating the total expenditure. So first of all, let us find out what is the length of the boundary. And we know that length of the boundary is nothing but the perimeter. And perimeter or circumference for a circle is given as 2 pi r, where pi is the constant given by 22/7 and r is the radius. Now as given in the question, radius is 7 meters. So let us substitute here and find out the perimeter. So this can be taken as 2 into 22/7 into radius is given as 7 meters. So this 7 and 7 gets cancelled and the perimeter comes out to be 2 into 22, that is 44 meters. Remember friends, perimeter is a measurement of length and length should be taken always in terms of meters or centimeters as the case may be. Now since the radius is in meters, perimeter will be also in meters. So the total perimeter or the length of the boundary here is 44 meters. And the question says, what is the total expenditure if the cost of fencing is 120 per meter? So for 1 meter length, the cost is rupees 120. So what will be the total cost is the question. So total cost will be nothing but perimeter into the cost per meter. So we can say that total expenditure will be equal to the perimeter into cost per meter or per meter cost. So this can be taken as 44, that is the perimeter, into cost per meter is 120. So this comes out to be 5,280 rupees. So we can say that the total expenditure is 5,280 rupees. So this is how, by using the formula for perimeter or circumference of a circle, we can find out the answer for the given question. Likewise, instead of a circular field, there can be a rectangular field or a square field or any type of two-dimensional shape. We need to find out the perimeter and then multiply with per meter cost to get the total cost of fencing. And the other point that we need to understand here is, it need not be fencing always. It can be any other activity where we are working on the boundary. For example, let's say a person has to construct a compound wall along the boundary of his premises. So construction of compound wall is again on the perimeter. So if the cost of construction per meter is given, then we can find out the total cost. Let us now take the second example from model 2 of mensuration. The floor of a rectangular auditorium of length 40 feet and breadth 28 feet is to be covered with a wall-to-wall carpet. Find the total cost if the carpet costs rupees 72 per square feet and the pasting charges is rupees 6 per square feet. So as you can see here, there is a rectangular auditorium as shown in the figure. Length is 40 and the breadth is 28 as given in the question. 40 feet and 28 feet. Now the floor of this rectangular auditorium has to be covered with a wall-to-wall carpet. That means nothing but we are placing a carpet on the rectangular floor. The carpet costs rupees 72 per square feet and the pasting charges is rupees 6 per square feet. We are supposed to find out the total cost. Now if you observe here, when we put a wall-to-wall carpet, we are actually working on the complete area of the rectangular floor. That is nothing but the area occupied by the rectangular auditorium. Now we know that area of a rectangular auditorium is equal to length into breadth. The length as given in the question is 40 feet and the breadth is 28 feet. So 40 into 28 is 1120. And here the units will be 1120 square feet. Why? Because both length and breadth are in terms of feet. So area will be in terms of 1120, that is 1120 square feet. That means the total area of this auditorium here is equal to 1120. Now we need to put a carpet across this area of 1120 square feet. And the cost of carpet is 72 per square feet and the pasting charges is rupees 6 per square feet. So what will be the total cost? So as you can see, because we are working on the area of the floor, we first need to find out what is the area. And then that area multiplied by the cost will give us the total cost. Now here, the carpet cost per square feet is rupees 72 as given. And the pasting charges, the pasting cost is rupees 6 per square feet. So altogether for 1 square feet, the cost is 72 plus 6, that is 78. 78 per square feet. But we have to work on 1120 square feet. So I can say the total cost here will be equal to 1120 square feet multiplied by cost per feet, that is 78. So when simplified, this comes out to be 87,360 rupees. So we can say that the total expenditure or the total cost of laying a wall-to-wall carpet on this rectangular auditorium will be 87,360 rupees. Similarly, instead of a rectangular auditorium, we can have any other shape. For example, it can be a square hall or it can be a circular auditorium. Whatever be the case, first of all find out the total area, then multiply by the cost per square feet to get the required answer. So that is the difference between example 1 and example 2. In example 1, as you have seen, we were working on the perimeter. So first we find out the perimeter and then find out the total cost. And in example 2 here, we are working on the area. So first we need to find out the area and then multiply with the per square feet cost to get the total cost. One important point that I would like to mention here is, as given in this question, we are laying a wall-to-wall carpet on this rectangular floor. But other than wall-to-wall carpet, there can be many other actions which are done on the floor. For example, the question may talk about floor polishing. There is a rectangular auditorium where floor polishing has to be done and the cost per square feet is given to us. So even in that case, we can understand that when we polish the floor, we are actually working on the area. Or let's say the total flooring is being done. Tiles are being laid. So cost per square feet is given to us. So again in this case as well, when we are laying the tiles or when we are doing the flooring of the hall, we are actually working on the complete area. So in all these type of cases, we need to find out the area and then find out the total cost. So we should be properly able to decide that is it the area or the perimeter on which we are working. And then when multiplied by the cost per unit, we can get the required answer. Let us now take the third model from the topic of mensuration, where we shall discuss questions related to finding the area of a footpath or garden which has been constructed outside or inside of a two-dimensional shape. Let us look at the first example here. A rectangular park of length 20 meters and breadth 18 meters is to be bounded by a 2 meter wide jogging track from outside. What will be the area of the track? So as you can see here, there is a rectangular park. The length is 20 meters and the breadth given here is 18 meters. Now this rectangular park has to be bounded by a jogging track, and this track here is 2 meters wide. And this track is constructed outside the rectangular park. So we need to find out what will be the area of the jogging track. Now, as you can see, this is how the shape would look like. For example, the inner rectangle that we see here is the actual rectangular park. This is the rectangular park which the question is talking about. So the given length here is 20 meters. So this length is 20 meters and the breadth is 80 meters. So breadth here is equal to 18 meters. Now outside this rectangular park, a jogging track has been constructed. As you can see, the jogging track has been constructed and this track is 2 meter wide. So 2 meters is the width of this track. So at all sides it is 2 meters. So on all the 4 sides we can say that the width of the track is going to be 2 meters. And the question is, what is the area of the track? So we need to find out the shaded portion here. This area has to be calculated. So this is nothing but the jogging track which has been constructed and we are supposed to find out the area. If you try to observe this figure, the shaded area here can be calculated by taking the outer rectangle area minus inner rectangle. So from the complete rectangle, outer rectangle, if we subtract the inner rectangle, the remaining area will be the area of the jogging track. So we can say area of the track or the required area will be nothing but outer rectangle minus inner rectangle. Let's take it as outer rectangle minus the inner rectangle. So area of the track will be area of outer rectangle minus area of inner rectangle, and area of a rectangle is nothing but length into breadth. So now we need to know what is the length and the breadth of outer and inner rectangles. Now for the inner rectangle, directly the length and breadth are 20 and 18, as this is nothing but the rectangular park. We only have to check what is the length and breadth of the outer rectangle. Now if you observe, the length of the outer rectangle, let us take it as L dash, will be equal to the 20 meters length, that is the length of the park, plus 2 meters extension on right side and 2 meter extension on left side. So 20 meters plus 2 meters plus 2 meters. This is going to be the length of the outer rectangle. Why? Because 20 is the length of the park, and on both the sides it has been extended by 2 meters because of the jogging track. So total length will be 20 plus 2 plus 2, which is equal to 24 meters. So this will be the length L dash of the outer rectangle. Similarly, the breadth B dash here will be equal to, let us take the breadth as B dash, that will be equal to, inner breadth is 18 meters, that is the breadth of the park is 18 meters, and both on top as well as bottom the park has been extended by 2 meters because of the construction of jogging track. So total breadth here will be 18 plus 2, 20 plus 2, 22. So here it will be equal to 18 plus 2 plus 2, that is equal to 22 meters. So now we know that outer rectangle length is 24 meters and its breadth is 22 meters. Remember friends, most of the students go wrong in finding out the length and breadth of the outer rectangle. What they simply presume is the length will be 20 plus 2 and breadth will be 18 plus 2. That means they take length as 22 and breadth as 20 because the track is 2 meter wide. The point to be observed here is that 2 meter extension will be on both the sides. So that is the reason we should take 20 plus 2 plus 2 and 18 plus 2 plus 2. So don't take it as 18 plus 2 only and 20 plus 2 only for breadth and length respectively. It should be 20 plus 4 and 18 plus 4. So now we can say that the answer here will be L dash into B dash minus L into B. L dash, as we know, is nothing but the length of outer rectangle, 24, into B dash is the breadth of outer rectangle, that is 22, minus L into B. L is the length of the rectangular park, that is 20, and B is the breadth of the rectangular park, which is 18. Now 24 into 22 will come out to be 528, minus 20 into 18 is 360. So by taking the difference of these two, we get the required answer. 528 minus 360 will be equal to 168. 168, and the units here has to be meter square. Why meter square? Because we are measuring the area. Area will always be in terms of meter square or centimeter square or square of units. And because the length and breadth and width are given in terms of meters, this will also be in meters. So we can say that the area of the track which has been constructed outside the park will be 168 meters square. So this is how we can find out the area of the track or the footpath by taking it as outer rectangle area minus inner rectangle area. The only point where we need to be careful here is while measuring the length and breadth of the outer rectangle. Remember, it should be extended on both the sides but not only on one side. Similarly, in some cases it may be given that the track is constructed inside. For example, very clearly in this question we know that jogging track from outside. The rectangular park is bounded from outside. Sometimes the jogging track or the footpath is constructed inside the rectangular park. So in those cases where the footpath or the track has been constructed within the rectangular park, there outer rectangle will be nothing but the rectangular park and inner rectangle length and breadth have to be calculated. There we simply take it as 20 minus 2 minus 2 and 18 minus 2 minus 2. So the same concept is applicable, but only thing is we need to be careful. Is it constructed outside or inside? Let us now take the second example from model 3. The question here is the outer circumference of a circular track is 220 meters. Find the cost of leveling the track at the rate of 50 paisa per square meter if the track is 7 meter wide everywhere. So as given in the question, the outer circumference of a circular track. We have a circular track where the outer circumference is 220 meters. And we have to find out the cost of leveling this track at the rate of 50 paisa per square meter. And this track is 7 meters wide everywhere. So we can assume that the circular track here is as shown. This is like a circular track which is 7 meters wide everywhere. The width is 7 meters. Along any direction, the width is 7 meters. And the outer circumference is 220 meters. We have to find out the cost of leveling the track at the rate of 50 paisa per square meter. Now, if you observe, when we are leveling the track, we are actually working on the area of the track. So first of all, we need to know what is the area of this circular track. Now, the area here can be taken as outer circle area minus inner circle area. Now, to find out the area of outer circle and inner circle, we should know the radius of outer circle and inner circle. Let us assume that the radius of outer circle is capital R and that of inner circle is small r. Now as given in the question, outer circumference is 220. We know that circumference of a circle is 2 pi r. So outer circumference will be 2 pi capital R. Why? Because outer radius is capital R. This is equal to 220 meters. So this can be simplified as 2 into 22 by 7 into capital R is 220. So 220 here gets cancelled 10 times, 2 goes 5 times, and we can say R will be equal to 35 meters. That means the outer radius is 35. So outer radius R is 35. Now if the outer radius is 35, we also know that the track is 7 meters wide everywhere. So the distance between outer circumference and the inner circumference is 7 meters. So we can say that the inner radius R will be equal to 35 minus 7, that is 28 meters. Why? Because it is 7 meters inside the outer circumference. If this radius is 35, inner radius will be 35 minus 7. Why? Because the track is 7 meter wide. So we also know that the small radius or the inner radius is equal to 35 minus 7, that is 28 meters. Now to find out the cost of leveling the track, we should first of all know what is the area of this track. Area of the circular track here can be taken as outer circle minus inner circle. That is area of outer circle minus inner circle. Area of circle is pi r square. So this will be pi capital R square minus pi small r square. Capital R for outer circle, small r for inner circle. So if we take pi common, we get it as r square minus small r square. So by substituting the values, that is 22 by 7 is pi. Capital R is 35. So 35 square minus small r is 28 square. Now from this we can take it as 22 by 7 into, let's take 7 square common. If 7 square is taken out, 35 square will be 7 square into 5 square, and 28 square will be 7 square into 4 square. Why? Because 5 into 7 is 35 and 4 into 7 is 28. So 7 and 7 gets cancelled. This will be equal to 22 into 7 into 5 square 25, 4 square 16. 25 minus 16 is 9. So this is going to be the area of the track. The total area of the track is 22 into 7 into 9 meters square. Why? Because all the dimensions here are in terms of meters. But as given in the question, we are supposed to find out the total cost, and the cost per meter square is 50 paisa. That means for 1 square meter, the cost of leveling is 50 paisa. So what will be the cost for this much of area? So we can say the total cost will be equal to the area multiplied by per meter cost. 50 paisa is nothing but half a rupee. So it can be taken as half rupee per square meter or 0.5 rupees per square meter. So total cost will be 22 into 7 into 9. That is the area into 0.5. 0.5 is nothing but the cost per square meter. By simplifying this, we get the answer as 693. 693 rupees. So 693 is the answer for the given question. So this is how, in cases where we have a footpath along the boundary of a particular two-dimensional shape, we can always find out the area as outer shape minus inner shape and then find out the required answer. Let us now take the fourth model from the topic of mensuration, which is based on painting the walls of a given room. The question says, all the 4 lateral walls and the ceiling of a room of length 12 feet, breadth 10 feet and height 8 feet are to be painted. Find the total cost if the cost of painting is rupees 15 per square feet and the doors and windows occupy 40 square feet of area. So here, as given in the question, there is a room of length 12 feet, breadth 10 feet and height 8 feet, where all the 4 surrounding walls and the ceiling have to be painted. The doors and windows occupy 40 square feet of area and the cost of painting is 15 rupees per square feet. So from this information, we need to find out the total cost of painting this room. From the question, we can understand that the room here is in the shape of a cuboid. Why? Because length, breadth and height all are different. And in this cuboid, we have to paint the 4 surrounding walls and the ceiling. So the total area to be painted can be taken as the lateral surface area of the cuboid plus the area of the ceiling. Or it can also be taken as the total surface area of the cuboid minus the area of the floor. Why? Because total surface area includes area of all the 6 walls, that is the 4 surrounding walls and the base and the top. So from this, if we subtract the area of the floor, we get the required area to be painted. So very clearly, the area to be painted can be taken the lateral surface area of the cuboid plus the area of the ceiling. And from this we need to subtract the area that is occupied by doors and windows. Why? Because doors and windows are not painted. So that has to be subtracted. So area occupied by area of doors and windows, we can say area of doors and windows. Now by using the relevant formula, we can find out the total area to be painted. That will be equal to the lateral surface area of a cuboid is equal to 2h times L plus B. That is 2HL plus 2HB. Plus area of ceiling. Area of ceiling is equal to area of the floor. Why? Because both ceiling and floor area are equal in a cuboid or in a rectangular room. And area of floor is nothing but length into breadth. So we can say that area of the ceiling here is length into breadth, LB, minus area of doors and windows, that is given as 40 square feet. So this is taken as 40. Now let us substitute the values here. That is 2 into height here is given as 8, L plus B is 12 plus 10. Plus L into B is 12 into 10 minus 40. So this comes out to be 16 into 12 plus 10 is 22. 16 into 22. 16 into 22 will be equal to 352. 352 plus 12 into 10 is 120 minus 40. So this will come out to be 432 square feet. So we can say that the area that has to be painted is equal to 432 square feet. Why? Because 352 plus 120 is 472. 472 minus 40 is 432. And the cost of painting is rupees 15 per square feet. So the total cost of painting can be taken as rupees 15 per square feet into the number of square feet which have to be painted. That is 432. So this comes out to be 6,480 rupees. So that is the answer for the given question. And as I have mentioned earlier, the area to be painted can also be taken as the total surface area minus the area of the floor minus the area of doors and windows. So either we can find out the total area to be painted by taking it as lateral surface area plus area of ceiling minus area of doors and windows. Otherwise, total surface area minus area of the floor minus area of doors and windows. Why? Because these two areas are not to be painted. The floor is not painted and the area occupied by doors and windows is not painted. So from total surface area, if we subtract these two, we again get the same answer. That is, the area to be painted will be 432 square feet. And then multiplied by per meter cost will give us the total cost of painting this room. Let us now take another example from model 4, which is based on the surface area of a three-dimensional geometric shape. The question says, what is the approximate area of the canvas required to make a conical tent of radius 30 feet and height 18 feet? So here we have to find out the area of the canvas required. Area of the canvas is nothing but the cloth which is used to make a conical tent. The radius is 30 feet and the height is 18 feet. Now we know that a conical tent will appear as shown in the figure here. The radius is given as 30 feet. The radius is 30 and the height is equal to 18 feet. We are supposed to find out how much canvas or how much cloth will be required to make this tent. Now very clearly, if you observe, when we make a conical tent, the cloth is not required in the base. The cloth is required only for the curved surface or the lateral surface. So here the area of the canvas will be nothing but the curved surface area of the cone, and we know that curved surface area of a cone is equal to pi r L, where r is the radius of the cone and L is the slant length of the cone. Remember, don't take the area of canvas as total surface area. Why? Because in total surface area we take curved surface area plus the area of the base circle. But we very well understand that while making a tent, the cloth is not placed on the base, or that circular piece of cloth is not required. We only use canvas cloth to make the curved surface. So the answer here is nothing but the curved surface area, which is pi r L. Now from the question we know that radius is 30 feet and the height is 18 feet. And in the answer here, radius and slant length L is required. And slant length L can be calculated as root over r square plus h square. Why? Because slant length, height and radius make a right angle triangle. And in any right angle triangle, the Pythagoras theorem holds true. That is, hypotenuse square should be equal to base square plus height square. So going by that, we can say L equals to root over r square plus h square. So by substituting the values of r and h, that is r is 30, so 30 square plus h is 18 square. We get this as 900 plus 324, that is equal to 1224. So the slant length L will be root over 1224. And root over 1224 can be approximately taken as 35 feet here. Why? Because 35 square is 1225. This is very close to 1225. So approximately the answer here can be taken as 35. So we know that the slant length is 35. Now by substituting the values there, we get the required answer. So area of canvas or the area of canvas cloth will be equal to pi RL, which is 22 by 7 into radius is 30 feet and L that we have got here is 35. Now 7 here gets cancelled 5 times. So 5 into 22 is 110 into 30. So the answer here comes out to be 3300 square feet. Why are we taking the units as square feet? Because this is area. Area is always measured in terms of square units. And because the unit of length here is given as feet, answer should be taken in terms of square feet. So we can say that the total area of the cloth required to make such a conical tent will be 3300 square feet. So this is how we need to identify which formula is to be applied, and then simply by substituting the given values we can find out the required answer. Let us now take the fifth module from this topic of mensuration, where we are going to discuss questions related to the volume of solid shapes. This is a very important concept from mensuration which can be used to solve number of questions from this topic. Let us first have a look at the given question. A metal sphere of diameter 16 cm is melted and small balls of radius 2 cm each are cast from the molten form. How many such small balls will be formed? So as given here, there is a metal sphere of diameter 16 cm. It is first melted, and from the molten form or from that liquid that we get, we form small balls of radius 2 cm each. So the question is, how many such small balls will be formed in this case? One important point that we need to understand here to solve such questions is that whenever a solid is converted from one form to the other, its volume remains constant. That is, whenever one solid shape is constructed to some other solid shape, or maybe same shape of different size, the various parameters may change, but volume will always remain constant. So the concept here is that volume should always be constant. Whenever conversion of solid takes place, volume is to be taken as constant. That means total initial volume should be equal to total final volume. Initial volume should be equal to the final volume. Right? So not only in case of sphere changing to sphere, even when we change a sphere into a cylinder, or let's say a cube is converted into a cone, so the various parameters like area, total surface area may change, but the volume of both the objects will remain constant, or the total volume remains constant. That is, whatever is the total initial volume, that should be equal to the total final volume. Now in this case we find that a metal sphere of diameter 16 cm is melted. So initially we have only one metal sphere of diameter 16 cm. It is melted and then small balls of radius 2 cm each are cast from it. Now a ball again is a sphere itself. That means here sphere is being converted into small spheres of radius 2 cm each. So we are supposed to find out how many such small balls or how many such small spheres will be formed. Initially we have only one large sphere of diameter 16 cm. But after conversion we have number of small spheres of 2 cm each. So total initial volume will be nothing but volume of this large sphere, and total for the final volume will be equal to the volume of each of the small sphere multiplied by the number of spheres. Let us assume the number of spheres that are formed is equal to n. The number of spheres or balls as given in this case is equal to n. So initial volume or total initial volume will be 4 by 3 pi r cube. That is nothing but the volume of a sphere. This should be equated to n into 4 by 3 pi, let us take it as small r cube. So this is the volume of the larger sphere. Capital R is the radius of the larger sphere, the initial sphere. N is the number of spheres formed, and small r is the radius of each of those small balls which are formed. So by simplifying this equation, we can find out the required answer. Now we find that 4 by 3 pi and 4 by 3 pi gets cancelled on both the sides. So we have capital R whole cube equals to n into small r whole cube. Capital R is nothing but the radius of large sphere. Now as given in the question, the diameter of that metal sphere is 16. If the diameter is 16, radius will be 8 centimeters. Why? Because radius is equal to diameter by 2. So 16 by 2 will be equal to 8. So this can be taken as 8 cube. This should be equal to n into small r is given as 2 centimeter each. That means the radius of each of those small balls formed is equal to 2 centimeters. So this should be taken as 2 cube. So by simplifying this, we get n equals to 8 cube by 2 cube. 2 cube is nothing but 8. So 8 cube by 8 is 8 square, which is equal to 64. So we can say that the number of small balls that are formed in such a case will be equal to 64. So this is how we can use this concept of volume being constant whenever a solid is converted from one form to other. So simply apply that total initial volume equals to total final volume. Let us now discuss another example from model 5 of mensuration, which is again based on keeping the volume constant. The question says find the number of bricks each measuring 25 centimeters by 12.5 centimeters by 7.5 centimeters required to construct a wall 12 meters long, 5 meters high and 0.25 meters thick, while the sand and cement mixture occupies 5% of the total volume of the wall. Now if you try to observe, the given dimensions of the brick are 25 centimeters, 12.5 centimeters and 7.5 centimeters. That is the length, breadth and the thickness of the brick. And the wall to be constructed here is 12 meters long, 5 meters high and 0.25 meter thick. And it clearly says that the sand and cement mixture will occupy 5% of the total volume of the wall. And we are supposed to find out the number of bricks required in construction of this wall. We all understand that for the construction of the wall, bricks along with sand and cement mixture is required. That means again here we see that number of bricks along with sand and cement mixture come together to form a wall. So that's like small cuboids are coming together to form a large cuboid. These dimensions here show that the brick is like a cuboid. Again the wall also is like a cuboid. So again we can understand that the total initial volume should be equal to total final volume, or the total volume of bricks and the sand and cement mixture together should be equal to the volume of the wall. So let us assume that total volume or initial volume equals to the final volume. Here there is nothing like initial and final, but we can say that volume of bricks plus sand and cement mixture should be equal to volume of the wall. So we find that the concept is same. Instead of saying initial volume equals to final volume, the volume of all those things together should be equal to the volume of wall. And we know that the sand and cement mixture takes 5% of the wall. Let us assume that the volume of the wall is nothing but 100% of the wall. So volume of bricks plus 5% of the volume of wall should be equal to 100% of the volume of wall. Why? Because sand and cement mixture as given here is 5% of the total volume. Now we can now understand that the volume of all the bricks together, should be equal to 100% minus 5%, 95% of the volume of the wall. 95% of the wall. Right? Or otherwise directly also we can say that the volume of the bricks together should be equal to 95% of the wall. Why? Because 5% of the volume of wall is occupied by sand and cement mixture. Now volume of bricks is nothing but the number of bricks n into the volume of each brick. Volume of each brick as given here is 25 centimeters into 12.5 centimeters into 7.5 centimeters. But the point to be observed here is the dimensions of brick are in centimeters and the dimensions of wall are in meters. So we cannot simply take this in centimeters and this in meters. This has to be converted to meters. So 25 centimeter is nothing but 25 by 100 meter. 12.5 centimeter is 12.5 by 100 meter and 7.5 centimeter is 7.5 by 100 meters. Why? Because 1 meter equals to 100 centimeters. So by dividing all these three by 100 each, we get the values in terms of meters. So this is like 25 by 100 meter, 12.5 by 100 meter and 7.5 by 100 meter. This should be equal to 95% is 95 by 100 into the volume of the wall. Volume of wall will be nothing but length into breadth into height. So that is 12 into 5 into 0.25. All these are in meters, so we need not convert. So now if you observe, both the sides are balanced as meter cube. So by simplifying this equation, we can find out the number of bricks n, and that will come out to be 6080. So we can say that 6080 bricks are required in construction of such a wall of the given dimensions. So this is how, friends, whenever you see that two types of solids or number of solids are coming together to form another solid, then we always go for volume to be constant. That is, total initial volume should be taken as total final volume, and the required answer can be obtained. Let us now take the sixth module from this topic of mensuration, where we shall discuss some typical questions. Now the first example here says, squares of side 4 cm each are cut from each of the corners of a rectangular cardboard of length 20 cm and breadth 16 cm. What will be the perimeter of the remaining portion of the cardboard? So as you can see here, it says there is a rectangular cardboard of length 20 and breadth 16, which is as shown here. This is the rectangular cardboard, length is 20 and breadth is 16. Squares of side 4 cm each. That means squares of side 4 cm are cut from each of the corners. So from all the 4 corners, we cut out squares of side 4 cm. So these dotted lines represent the cutting out of the squares from each of the corners. Each square is of side 4 cm. So we need to find out what will be the perimeter of remaining portion of the cardboard. So as you can see, when these 4 squares are cut out from the rectangular cardboard, the remaining portion appears as shown in the second figure here. Now total length is 20. From 20 we have subtracted 4 centimeters from both the sides. So 20 minus 4 will result in 12. Similarly this side is 12. Likewise, talking about the breadth here, total breadth is 16, but 4 cm is cut at the bottom, 4 cm at the top. So this remaining portion will be 8 on both the sides. And inside we have 4 and 4 as the lengths. Why? Because these are squares which have been removed of 4 cm each. So we have to find out the perimeter of the remaining portion. We very well understand that perimeter is nothing but the length of the boundary or the length of the given two-dimensional shape. Now here the two-dimensional shape that we have after cutting out 4 squares from each of the corners is as shown. So the perimeter of this shape here can be taken as the sum of all its sides, that is 12 plus 4 16, 16 plus 4 20, 28, then we get 32 plus 4 36 plus 12 48 plus 4 52 plus 4 56 plus 8 64 plus 4 68 and plus 4 72. Altogether, by adding all these sides, we get the perimeter as 72. So we can say that the perimeter of remaining portion here will be 72 centimeters. Why? Because perimeter is a measurement of length. It should be in centimeters and the given units are in centimeters. So perimeter here will be equal to 72 centimeters for the remaining portion. But friends, if you observe, the perimeter of the actual rectangle also is 72 centimeters. But because length is 20 and breadth is 16, we know that perimeter of a rectangle is 2 times L plus B. So 2 into 20 plus 16, that is 36 into 2 will give us 72 centimeters. So you find that original rectangular cardboard perimeter is 72 centimeters. After cutting 4 squares from each of the corners, the perimeter again remains to be 72 centimeters itself. That means there is no change in the perimeter even after cutting out 4 squares from each of the corners. Let us understand why does this happen? Why does the perimeter remains the same? If you observe, after cutting out 4 squares from each of the corners, the shape of the cardboard completely changes and hence the area will also change, but perimeter remains same because what we have 4 and 4 in the original rectangular cardboard here has become 4 and 4 inside. So the only point is we are cutting it out but the length remains same. So while adding, if you observe, this part is 12, so this is 12 and we take this as 4 and 4. Only difference is after cutting out that square, this has become 12, inside we have 4 and then again we have 4. So no way the length or the breadth here is going to change. So that is the reason the total perimeter remains same even though the shape is changing here. But let me make it clear, this doesn't happen always. Only in this case, when we are cutting out 4 squares from each of the corners, the perimeter would remain same. So we should be able to understand this without even drawing these two figures and directly take the answer as perimeter of the original rectangle. So make sure that next time onwards when such type of questions are asked, you are able to visualize what happens and find out the required answer. Why? Because drawing these figures and then finding out the perimeter really takes a lot of time. So simply understand, when we cut 4 squares from the corners of a rectangular cardboard, the perimeter remains same. Area would be changing but perimeter remains same. Why? Because the net length and breadth of the rectangular cardboard remains same. Let us now take one interesting example from Model 6 of mensuration. The question says a pit of length 8 feet, breadth 5 feet and depth 4 feet is made in a rectangular field of length 34 feet and breadth 20 feet. The earth dug out of the pit is uniformly spread on the remaining area of the field. What will be the increase in level of the remaining area? So as you can see, a pit of length 8 feet, breadth 5 feet and depth 4 feet is made in a rectangular field of length 34 feet and breadth 20 feet. So this is the rectangular field of length 34 and breadth 20. Inside this rectangular field of length 34 and breadth 20, a pit of length 8, breadth 5 and depth 4 feet is made. That means here is the pit which is of length 8 and breadth 5 and the depth is 4 feet. Understand friends, this is the top view of the field. This pit what is being made here is dug inside up to 4 feet. Now the earth that comes out of this field, earth is nothing but the sand and the mud that comes out, is uniformly spread on the remaining area. So whatever quantity of mud or earth that we get out is uniformly spread on the remaining area of the field. So that is the remaining area. This is the remaining area on which that mud is spread uniformly. So the question says what will be the increase in level of the remaining area. It is obvious that when we spread the mud uniformly on the remaining area, there will be an increase in height, there will be an increase in level. So what will be that increase in level is the question here. Now to solve this question, we need to first find out how much of earth is dug out from this pit. That is, how much volume of mud comes out from the given pit. Volume of this pit will be nothing but volume of the cuboid. Why? Because this pit is in the form of a cuboid. Length 8, breadth 5 and depth 4. So we know that volume of a cuboid is length into breadth into height. So it can be taken as 8 into the breadth is 5 and height is nothing but the depth here, that is equal to 4. So 8 into 5, 40 into 4, 160. This is 160 cubic feet or 160 feet cube, because volume is always measured in terms of units cube. So cubic feet here. So this much of earth or this much of mud is taken out from this pit. And on the remaining area, it is spread uniformly. Let us now find out what is the remaining area. Remaining area, as you can see here, is nothing but this total rectangular field minus the area occupied by this pit. So remaining area can be taken as area of field minus area of the pit which has been dug out. Now the area of the field can be taken as length into breadth. Why? Because it is a rectangular field. So this will be equal to length into breadth, that is 34 into 20 minus area of the pit. Again the area of the pit here is length into breadth. Why? Because this is also in the form of a rectangle. So 8 into 5. Length is 8 and the breadth is 5. So 34 into 20 is 680 minus 8 into 5 is 40. This comes out to be 640. 640 square feet. Remember, this is area. Area is always measured in terms of square units. So because the lengths and breadths here are given in terms of feet, area will be 640 square feet. So now we know that 160 cubic feet of earth has been dug out and the remaining portion on which the mud is spread uniformly is 640 square feet. We have to find out what will be the increase in level. Again friends, going by the concept of volume being constant, that is, whatever volume of earth that has been taken out, the same volume has to be spread uniformly over the remaining area. So one volume that we know is 160 cubic feet. Now this should be balancing the remaining area into the increase in the level. So we can say that the remaining area into the level which has been increased, the rise in level should be equal to the volume of the pit. Volume of pit. Why? Because the volume that we have taken out from the pit has to be spread uniformly over the remaining portion. So remaining area is known to us. If we multiply the remaining area by the increase in level, we get the volume of the pit. So by balancing this now, we can find out the increase in level. Remaining area, as we know, is 640 square feet into, let us take the increase in level as L. This should be equal to the volume of the pit is 160. So from this we can say that L is equal to 160 by 640. This is 160 cubic feet and this is 640 square feet. So upon simplification we get 1 by 4 feet. 1 by 4 feet is nothing but 0.25 feet. So we can say that the level of the remaining portion will raise by 0.25 feet or 1/4 of a feet. So this is how we can solve such typical questions from mensuration by analyzing the shape or figure as given in the question and by applying the relevant formula. So make sure that you remember all the formulae related to 2-dimensional and 3-dimensional figures and apply them at the right place. That's all from this topic of mensuration. See you in the next session. Thank you.